Okay, now today your homework assignment is to keep on working on that, on the first milestone for your project. And I had intended to get your last homework assignment back by now so that we could talk about it, but I don't have those ready for you yet. So it'll be either tonight or tomorrow. But I have already looked at all of your programs and I have some comments to make. So a number of you have to change your ways here. Now, I finally figured out at one point during, in the sequence of teaching this class for a number of years, I finally figured out to forbid you to use, what is it, integer dot, no, parcent. Yeah, I've figured out you cannot do parcent. There's another one that I'm going to forbid you to use.
Like casting it?
No, that's good. Okay, the one that you cannot, I'm going to forbid you to use, is it math.pow?
Oh, I did that.
Yeah, I know. A number of you did. Confession is good for the soul. Anyway, so forbidden. It's a forbidden fruit. Forbidden to use math.pow. Is that what it is? Is that the name of the function? Okay, now, because look, inside math.pow is undoubtedly some kind of a computation that involves a loop. And we have this really slick technique here in figure 7.35. Look at what it says. Case ls sign, local int val equals 10 times local int val plus next char minus 0. No math.pow there. This is your model. I'm giving you these programs as models of how to do your assignments. And so you should use this technique because this is way inefficient. You see, notice that there's no call to any math at all. And some of you guys, I saw some where, to get the hex value, they took the length of the string and then in a loop went through and did the pow and the length to, anyway, there's lots of complication stuff. And so on some of your programs, I'm including the complete solution. And what you should do is if you did it real complicated, you need to compare your solution with this solution that I'm providing and ask yourself, and when you start coding, from now on as you code, you need to think about how you did it and how you should have done it to simplify. There's a famous quote, I think is Pascal is the one who wrote it, and I think this is very germane. He was writing a letter to his friend, and at the end, and it was a long letter, and at the end of the letter he said this. He said, I would have written you a shorter letter, but I did not have the time. Now think about that. I would have written you a shorter letter, but I did not have the time. What's he saying? What he's saying is that it would have taken me, it's easy to be verbose. It's difficult to pare away all that verbosity and get it down to the essentials. You understand what I'm saying? So look, it's easy to write code that you can just type in all that stuff. We're all fast typers these days. It works. Call pow, do a loop, It's difficult to look at that and say, how can I shorten it? How can I simplify it? How can I make it more elegant? And I can't stress hard enough that in these early stages, when you're first learning how to code, you need to learn how to make your code concise. It's hard. And most code has to evolve. I mean, you'll see in big software projects that I've been involved with, it's typical to start off with a really long program and then to think through and think, how can I simplify this? But it takes time to make it shorter and more elegant. And you need to do that. That's the difference between, maybe acceptable software that works and really good software and really great software. You see, there's quality. You understand what I'm saying? It's difficult, but that's one of the side benefits for doing a project like this is for us to get into the habit of being more concise. All right, so that's number one. And number two, the second thing I wanted to review is, so don't do this. Use this model. Okay. Oh, and another thing. Now, it's great for you to work in groups, and I know that when you work in groups that we get code that looks identical in submission, and that's fine with me. Only thing is, don't fall into the trap of, if you work in a group, letting someone else do the work and you just copy it and you just turn it in. Okay, and I decided to never try to enforce, programs that are identical submissions, because in the long run, if you have to do some coding, you're just hurting yourself, by relying on other solutions. Okay, so that's another thing. Oh, and also, I am providing, if you wrote a program that just was way off base, I'm providing you with a complete solution. Do your colleagues a favor and don't circulate those solutions, okay? Because it'll just, in that vein, it's better for you to write your own program, your own software, and go through the struggle of the software development process, and then seeing how it can be done better, and then that's how you learn. See what I'm saying? So I'd rather have you turn in a lousy program on your own than a good program that you worked that you didn't have to struggle with. But that's for your own benefit, Yeah. So anyway, and so I didn't enforce this in this assignment. In the future, I think I'm going to put this on the assignment sheet to forbid this. But definitely for the project is a no-no. Okay, you need to do it like we need to do it like this for efficiency, and also it's just more elegant code. Okay, doing this on the fly. In all of these, you guys, even in the next project, the next milestone will be the parser, and then the milestone after that will be the code generator. And on each of these, I'm giving you example programs that are similar to how to do it. But the techniques, you should adopt the techniques of the programs that I give you and use them as models of how to solve the programming problem. All right? So that was one thing I wanted to start off with today. And another thing I wanted to review is I want to make sure that we understand the difference between mutable and immutable strings in Java, because this is another side benefit of doing a project like this, is that we can learn a few software engineering principles. And so I just want to emphasize this one more time. And here's the difference. Okay, suppose we have two variables, and suppose we have type string, and we say my str. All right, suppose we have this. And so now, because this is a capital S string, is my string, is that mutable or immutable? That's immutable. And suppose we have another one called, or of type string buffer, and it's my string buff. All right? And obviously, is this one, the answer is obvious, but is this one mutable or immutable? It's mutable, right? And the difference is, and you can see, the thing, I just want to point out one more thing. The thing that you can see about this is how they are used. So if we have somewhere later in the program, we could do this. We could say, my string gets, quote, hello. And we could also say, my string buff gets hello. All right? I mean, these are legal in Java. But now here's the thing. Here's the thing that makes how you can tell. This is how you can tell whether whether this string is mutable or immutable. It's how you do operations on it. So if you want to concatenate world onto my string, here's how you would have to do it. You would have to say my string gets, quote, oh, sorry. My string gets my string plus quotes world. All right? Now, what is this doing? This is not changing, this is not mutating my string. What it's doing is it's taking the original value of my string, and this plus in Java is concatenation. When it's between two strings, it concatenates two strings. So this will take the original value of my string, and it'll actually make a copy of it. It'll actually make a copy of it. And then it will append world onto that copy. And then the original value of my string will be thrown away, and it will be replaced with that copy of this new constructed string. Now, does everybody see what we're saying there? That's how it would work. All right? So we are not mutating my string, but we are setting it to a new string. We're not mutating the original string. We're making a copy of the original string and doing an operation on that, making that construction, and then my string is getting that. That's different from the way here in figure 7.35 we see how the buffer, how to append to a buffer. So look, here in figure 7.29, 7.35, what do we see? We see, you see local string val what? Dot append. So there is a dot append that's available. Do you see? So how would you do this? You wouldn't say my string buffer gets my string buffer blah blah blah. You just say what? You say my string buff dot what? Dot append parentheses what? World. Now, do you see that there's an essential difference here? There's a big difference here. This one is appending my string buff. It's not making a copy of it and sticking another one onto it. It's taking that original one and doing it in place. Does everybody see? I just wanted to point out, this is the difference between mutability and immutability, and immutable strings and immutable strings. Okay, so I just wanted to point that out. Now, what I'd like to do for the rest of this time is to see how, what we did last time is we did a code walkthrough of this get token in figure 7.35, public abstract token get token. So get token returns an abstract token. What I'd like to do now for the rest of this time is to see how this gets called, right? Now let's go back and review the input and the output. So if we see here in figure 7.32, that string of characters, here is A47, 48B, space, new line, space, C, hyphen 49, A long identifier, blah, blah, blah. Okay, so it does, and that produces that console output on the slide there, right? Okay, so now let's, and this, by the way, is the format of the output that you should have, that your program should do. All right, so now let's see how the code that actually produces that, the higher level code that actually produces that. So here in figure 7.35 we have the tokenizer, okay, and we have get token, and we did the code walkthrough of get token. Now what we want to take a look at is figure 7.36, and this is the code that's inside action performed. And so this is what happens when the user clicks that button, that dialog button. Now check this out. Now, there's two things that we want to go over here. First one is what's this deal with the input buffer? How does that work? In action performed, we have a little local variable inside action performed, and that first variable, what is its type? Capital I in buffer, right? And then the object itself is lowercase I in buffer. And what does it get? New, yeah, it gets new. So what new allocates from the where? The heap. So it's getting this buffer from the heap. Okay, so it is new in buffer. And then here we have text area dot get text. So obviously what that does is that takes the text from the dialog box as a string and puts it in buffer. And we did the code here. We'll take a little quick look. So here in figure 7.30, here is class in buffer, and it says public in buffer, public class in buffer, and then we have the attributes in string, line, and line index. And the next we have public in buffer. So that in buffer is a method with the same name as the class. So that makes it the what? The constructor. And what did we give that constructor when we called it from down here? Text area dot get text. So you see that. Are you with me? Is that text area dot get text? Is that the actual parameter or the formal parameter? Yes, that is the actual parameter. All right. And so we come back up here to in buffer. Okay, and we see, so that actual parameter is lowercase s string. And what do we, and oh, by the way, look, it's of type capital S string. So what do we do? What's the first thing we do? We say in string gets, in string, which is the attribute, gets string plus new line, new line. So that's concatenation. All right, and so in string gets that. So does everybody agree then that after when we allocate our buffer with new, that constructor happens, and that in string has all those lines of input. Here's what I'm going to do. Let's take a look at action performed. So inside action performed. Okay, so action performed local variables. Now that's a local variable, so where is it allocated? On a runtime stack. Yeah, okay. So here's what I'm going to do. We're going to say now what's the name of our variable? In buffer, right? And so our variable here is called, so it's like in buffer. And what I'm going to put here is I'm going to put it's new, right? So what I'm going to do is I'm going to put a little pointer here, because when you take new it returns a reference. A reference is just a pointer. So it returns a reference to the buffer, and it's allocated from the heap, and it starts at that new line. Okay, so I'm going to just be kind of visual here and say, and this is a buffer. And now what attributes does this buffer have? This in buffer. What attributes does this in buffer have? Do you remember the three attributes it had? In string, line, and line index. So here we have in string, line, and line index. So anyway, there is an instance of this now, and this refers to this. Do you see what I mean? And so all that text in our input box, all of that text is inside in string. That's the value. So what did we say? A long identifier, blah 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 blah. That's the value of this. And that got allocated from heap. And so now that's all set up here. Is everybody clear on this? Now what else is in here? Not only do we have an in buffer, we also have what? A tokenizer, and that is what? Of type, the lowercase t is the name. So here's a little t, and what does it have? It's new tokenizer. All right, now here's where we conceptually, I want us to understand this. So tokenizer T gets new tokenizer. So because it's new, that means it's what? It's it's allocated from heap. Now what does the tokenizer have in it? We looked at that code last time. Does tokenizer have any local variables? Or any? Oh, tokenizer, yeah, so this T goes to a tokenizer. Okay, so here's tokenizer. Are you with me? And what attributes does a tokenizer have? It has a what? Private final what? In buffer B. So inside here there is a B. Right? Inside here there is a B. Are you with me? And does it have, all right? I think that's the only attribute it has, right? But now look, here in figure 7.35, private final input buffer B. but this says public tokenizer what? Tokenizer, that's a method with the same name as the what? As the class, therefore it's the constructor. So when we knew this, what does it do? What does it say there? It says what? Public tokenizer in buffer. What does it say? B gets what? In buffer. Now these are reference variables. So what happens is the value of B, look, now I'm not sure how to do this visually, but here's what's happening. Do you see that code says B gets in buffer? Well, what got passed in buffer? Is in buffer in figure 7.39 in the constructor tokenizer, is in buffer the actual parameter or the formal parameter? That's the formal parameter. Well, what was the actual parameter? Here in figure 7.36, what is the actual parameter? In buffer. Okay, so here this is our in buffer. So what does that make? So if we pass this and B gets this, what does that make B do? What does that make it do? Point to the same thing that in buffer is pointing to, because it's a reference variable. Now, is everybody clear on that? So what that does is that makes B point to this. We should conceptually see what's going on here. So what happened is this got allocated from the runtime stack. This got allocated from the runtime stack, and that's an in buffer. But we want to pass that reference our T, we want to pass that reference to the tokenizer so that the tokenizer can use the buffer. You see? So now everywhere so if we go back here to figure 7.35 and we see, look, here in figure 7.35, what does it say? Do. Next char gets what? B dot advanced input. Well, what's B? Well, it's B dot this. So it's advancing input of this, which got set up by this. Now, this is all very conceptual. All of these, every object, now here's the thing. Let me say another word about Java. There's a famous saying in Java that goes something like this. There are no pointers in Java, because Java doesn't have the star, you can't have pointer types. So the saying goes like this: there are no pointers in Java, but everything is a pointer. And what that means is that there's no asterisk, there's no star notation in Java. But on the other hand, every time you do a new, every time you have an object, objects are always pointers. They are called, in Java terminology, they are called reference variables. And a reference variable is really just a fancy way of saying a pointer. Do you see? So you think of a reference and a pointer as the same way. It's just different terminology in Java compared to in C++. Yeah.
So you can basically say any object gets any object, and then it'll point to...
That is an excellent point. Good call. So what he said was that in Java, when you say one object, if you say one object gets another object, that is it's a reference. It's what we learned in C++ as pointer assignment. It's the exact same thing. They just hide, what Java does is Java hides the fact that everything is pointers by just not even having the asterisk, the star, Okay, but that's because everything is a pointer, and anytime when you assign one object to another object, it's a reference. It's not copying it. It's a reference to that same object. Yeah.
But you still have to match like the type. Like the only reason we're allowed to do that is because little b is in buffer.
Yes, yes, it's still type. Right,
They can point
right.
to the in buff,
Yes,
but otherwise it wouldn't be allowed.
yes, yes. That is true. It still has to be. Java is strongly typed, just like C++. Yeah, that is one of the characteristics of it. Yeah, that is real. Yeah. So now here again, you guys, this is a side benefit. This is a side benefit. Learning all this stuff about Java is a great side benefit of doing this project. Okay. And I don't, as you noticed, we're just jumping into Java. I'm not giving you any tutorial stuff. If you want, you can find Java tutorials online a lot, but I think knowing C++, I think it's just, yeah.
This might not be like the most important question, but like, so if you were to like say delete in buffer.
Ah, that is the very important point. In fact, that's what I was going to bring up next. Here's another great thing about Java. Java has automatic garbage collection. So when those of you who took the data structures course, or if you were in the C++, anytime you did a new, you had to be careful to do a what? A delete. Well, Java, delete is automatic. You don't have to delete. It's not even part of the language. But now here's what happens. How do they do that? They do it automatically behind the scenes. That means you have no control over when the garbage collection algorithm is going to kick in. And it can slow your program down at unexpected times. So it's easier and safer, but what? Slower. Now, does that sound familiar? Is that a familiar trade-off? What did we say about Mutable? We said what? Safe but slow, dangerous but fast. We can say the same thing about garbage collection. C++, or Java. No delete, automatic garbage collection, safe but what? Slow. C++, you have to do your own deletes, and you can have, remember the memory leak problems? No memory leaks in Java if it's done automatically. Okay? So that's dangerous. Dangerous, but what? Fast. Nah, there will always be that trade-off. You see, is everybody with me on this? It's also, remember when we did interpreted? Do you remember the difference between interpretation and compilation? Remember that slide? I don't want to bring it up now, but Java is an interpreted language. So what happens when you compile Java, does it compile down to machine language, yes or no? It does not. What does it compile down to? Java bytecode. And then that bytecode does not, the CPU does not execute the bytecode. What does the CPU execute? The what? The JVM, yes, the Java virtual machine. So it's actually when you run a Java app, the app is not actually executing. The Java virtual machine is the machine language program that is executing, and it is taking the Java bytecode as input as well as the input of the app and producing the output. Okay, so here again, that's another reason why Java is what, but what? Slow, that's because it's not it's an interpreted language. Okay, so all these features of Java, the trade-off was all towards portability, safety, but at the expense of execution speed. Okay, so anyway, and all of this stuff is good for you to know, software engineering stuff that's practical, all right? And also, you guys, I'll just tell you this right off the bat. We have another exam coming up here, I don't remember when. A week from today? A week from today? Oh, you're right, because the assignment, the milestone is due Monday, yeah, a week from today. But let me just tell you another thing in preparation if you want to start studying for that. None of this Java code is going to be on it, okay? So if you want to start studying for the exam and you want to optimize your study time, it's going to be, I'm not going to bother, because this is just kind of a side, we're doing this big project in Java, but none of this Java code will be on the exam. We're more interested in the principles, all the theory will be, all the the finite state machines and all that kind of stuff. But the implementation of them with Java is, this is for our benefit to learn, but it won't be, I won't test you over this. All right, now is everybody clear on how this works? Now, so let's continue our, oh, you mean the fact that this is pointing to this part of the box and this is pointing to this part of the box?
Yeah, why wouldn't it be pointed like that?
Yeah, no, hold on. Yeah, it does. I just drew it this way. Are you with me? Yeah, this is pointing, I meant this whole box is like one thing. If it points to the whole box, it points to the whole, are you talking about why didn't it like point to this part of the box?
No,
The little box.
Oh, no. Oh, that's a good thing. No. Oh, you see, you're saying, why didn't this point to this?
yeah.
No, if you review the example of pointer assignment, I think we did this in C. If you have 2 pointers, actually this is a good question. Let's review that. If you have 2 pointers, A and B, and if you say A gets B, that makes A point to what? It makes A point to the thing that B is pointing to. It doesn't make A point to B. That's why. Yeah, that was a good review question. Is everybody clear? Yeah, that was a really good question. Why doesn't, yeah, but that's because of the nature of pointer assignments. And that all is related back to this question, this point that Java variables are reference variables. They are all really, since we learned C++ first, we can think of them as pointers. Yeah. All right, so continuing on in figure 7.36. In buffer gets in buffer new, in buffer text area get text, tokenize. So we did all this time on the first 2 lines. And now what else does it have? What else does action performed have? It has what? A token. So here it also has a token. And it's a type capital A token. And then what does it do? It does in buffer dot what? GetLine. Now do you remember we worked through what getLine did? Do you remember what it did? Do you remember what getLine does? Here, let's go back and review it. In figure 7.30, remember what getLine does? Int I gets in-string dot index of the what? New line character. So that makes I point to the first new line at the first string, the first line, the first new line in the string, which is at the end of the first line of text, input text. Line gets what? In-string dot substring from 0 to so that makes line get the first line, and then the next one does what? Peels off the what? Peels off, yeah, it peels it off. Okay, so in-string gets in-string dot substring I plus 1. So that peels off the first line. And then line index gets 0. Okay, so that sets up the buffer for starting to stream from the first line. All right, so that's in buffer dot getLine. And now check this out. We have a nested loop. So what do we say? While in buffer dot input remains. Now remember, we guaranteed that at the end of the buffer we concatenated 2 new line characters. We guaranteed that the last line is going to be how long? 0. All right. So in buffer gets. So while in buffer dot input remains. Okay. So that's one big while loop, and then do. So now we have a do inside of a while. Now this is do what? What's the code there? A token gets what? T dot get token. So what is T? T is this tokenizer. Okay, T is this tokenizer. T dot get token. So but it's calling the tokenizer. The tokenizer has access to this, so it runs through and the first token, and that A token. What would the value of A token be with this example input? Identifier equals here. So here in figure 7.32, it would scan the HERE in the space and boom. And so what would it return? So A token would be here at this point. A token would be what? It would be an identifier token with, what do we call that? T identifier? I think so. It would be a T. It would be a. I'll just verbalize it. An identifier token with attribute what? With attribute value of what? Here.
Oh, yeah.
See, that's what it would be. Here would be wrapped up. That would be inside the attribute of the token. You see? Does everybody see what that would do? And then system.out.println what? A token dot what? Get description. But wait a minute. We have a number of get descriptions, don't we? I think we have a problem here, don't we? Because look, is it going to do the get description of T empty, or the get description of T invalid, or the get description of T integer, or the get description of blah, blah, blah? What's it going to do? Oh no, it doesn't know. We don't know. Polymorphic dispatch. Right? It looks at the polymorphic. Is everybody clear that that's polymorphic dispatch? Here, in this code right here, when it says system.out.println a token.getDescription. Trick question. I will ask it again. What is the type of a token at this point? Trick question. Because a token actually has what? Two types. What are they? Static type and the what? Dynamic type. The static type of a token is what? Big A token. But this, so how does it know which get description to execute? It looks at this at its what? Dynamic type. And because the dynamic type is a T integer, it goes to this one and it executes the get description of this one. Now is that slick? Now look, this is cool because if we didn't have polymorphic dispatch, what would we have to do with this print line? We have to say, if it's this kind of token, output this one. If it's this kind of token, output this. Else if it's this kind of token, output do it this way. You see how this works? That's really good object-oriented programming. So now what it does a token gets t.get system.println a token. While what? Not a token what? Instance of t empty, and not what? A token instance of invalid. So is that true here with this token? Yeah, question? That is exactly right. The difference is where the test is. In a while loop, the test is always at the top. Therefore, it is possible for the loop the body of the loop to never execute. With a do loop, you must guarantee that it's safe to go through the body of the loop at least one time, because the test is at the bottom. Yeah. And in this case it is. Why can we do that in this case? Why do we use a do instead of a while? Because what did we guarantee when we set up our buffer the very first time? What did we guarantee? Those new lines. Does everybody see how that guarantees that? See? That's a guarantee. We need to be able to prove that it's correct. We can prove that it's correct by looking here at figure 7.30. I don't care even if the user put nothing in that dialog box and pressed return. Our program would execute correctly and would not crash.
Is that next?
Yeah, let's talk about that. Excellent, man. You're asking questions that I was. Yeah, I'm glad. I couldn't pay you to ask a better question. Yes. So let's summarize. Let's summarize what these loops are doing. So what's happening is it's while in buffer.input remains. Okay, so that outer while loop executes once per what? So here. So these are notes on figure 7.36. Yes. So here's the point. The while loop executes what? Executes once per what? Per line of input. Are you with me on that? And because it says while input buffer dot input remains. And furthermore, what do we have just before the while? In buffer.getLine. What is that doing? That is guaranteeing the what? That the invariant is true before we execute the loop the first time. Because the invariant is that getLine has been executed, and therefore line, and we are at the start of the next line to be scanned. Okay? And then what is the last instruction in the while? In buffer.what? What is it? The very last instruction in the while loop. In buffer.what? GetLine. So when we go back, regardless of whether we enter the loop from the top or we execute the loop and we enter it from the bottom, we know, because of that while, we know that if we do the body of the loop, that there is a line of input to process. Are you with me? And now, you guys, what about the do? Executes once per what? Yeah, which one is it? Is it character or is it token? It's token. So because it says what? Because what is it? What's the very first thing it does? It does what? A token gets what? t dot get token, and then print blah, blah, while what? Token instance of t, blah, blah. Now, do you see from this, do you remember how we looked at the behavior when we had a syntax error in the middle of a line? Do you remember how we had da 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 and it skipped a line? Now, do you see that this does that? Because there's no need, once you find an error, there's no need, once the line is erroneous, the whole line is bad. So, well, yeah, anyway. Yeah, you know, and also it's more, see, this is we want to keep it simple. Yeah, we want to keep it simple. Does everybody see that that's what that does? Right? This code is responsible for that behavior. Okay? So the do loop executes once per what? Per token in a single line. All right? But now look, we saw that when we called get token, what is the code? How many loops does get token have in it? Let's go back to get token. So this is figure 7.36 and 7.35 here. So here in figure 7.36, 7.35. How many loops does get token have in it? So here's the initialization, blah 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 blah. And what do we have here? Now what do we have here? How many loops? 1. Are you with me? So this is figure 7.36. This is figure 7.36. And our point here is, how many times does this loop execute? In 7.35, well, how many times does this loop execute?
The loop that we're talking about, the switch loop?
No, switch is not a loop.
The if loop there?
If is not a loop. That's an alternative. No, hold on. You understand that when you use the word loop, it's repetitive. Switch is not repetitive.
Okay.
Are you with me? If is not repetitive. If is not a loop. Switch is not a loop.
Then which are we talking about?
That do at the top.
Oh.
That do at the very, see look, that do is, see this is part of get token, blah blah blah, here's the initialization, and there's the do at the very top. Now how many, are you with me? Once per character within a what? Token. Alright, so the do loop executes per character in a single what? Yes. And this is 7.35, the code in figure 7.35. So look, and here's the thing, you guys, and some of you guys did this ad hoc. I was, you know, some of you in this parsing, this one that I'm going to be, that I'm grading the previous assignment. Some of you guys did it. One of you guys, I'm not naming names, I don't even remember, didn't even use a finite state machine. Just boom, 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 boom. Okay, and look, look, you guys, this code is a model for your project. Do it the way this is, you're to imitate this code. All right? This code is a model. All right? So use these techniques. And look, I have seen, if you don't do this according to the theory of finite state machines, then it's very, very easy to get bugs, to have bugs in your code. Here, let me give you an example. I used to have students until I just forbade it. I used to have students, you know, oh, what about leading spaces? We'll have a little loop, do the leading spaces. You know, see what I'm saying? And then you have a loop inside of a loop and no, you don't need all that complexity. You see what I mean? And what about trailing spaces? Oh, we know it's the end. Now, are there trailing spaces? Now, have a loop for the trailing spaces. How about the whole bunch of spaces in the middle? Oh, we'll have a loop to consume the trailing spaces in the middle. Oh, let's write a little function that does the spaces, blah, blah, blah. No, you don't need any of that junk. Look, there's only 3 loops. They are nested, and it's this. You got to structure your code like this for the project that's due on Monday. All right? There's only 3 loops, and that should be the only, and no POW, no math.pow. All right? No parseInt. Okay? And this is the concept. This is how the code works. And I'm telling you guys, this is the way it's going to be. You will incorporate this in your project. Okay? And what we're doing for this one is we're just printing out the the tokens. And so again, here again, I leave you with this, like we did last time. Your job is to implement figure 7.53, but use this pattern. Okay? Anyway, so see you on Monday.